Hello, dear followers of the Cruz Spatial channel. I am Rafael Cruz, and today's video we are going to study about satellite-based position systems of the book Positionals in Wireless Communication Systems.
This video is about the book, Positioning in Wireless Communication Systems.
Okay, my friends, let's start. In topic 1.2, named Satellite-Based Position Systems, we have to learn about position systems in global or Earth, okay? And when talking about position systems, people usually have in mind the global position systems, or very familiar GPS, the North of America, okay? Operated by the United States Air Force for Department of Defense, or DoD. GPS is probably the most well-known representative of today's global navigation satellite systems, GNSS, okay? And after we talk more about this GNSS, okay? And however, there is a further satellite-based position systems in operations. For example, the Russian Global Navigation Satellite Systems, or GLONASS, okay, or the Chinese Beidou systems. We pair in these systems. Uh, we have the word global, okay. In this case, we talk to and coordinate or coverage in our global access. Okay, let's go. Currently planned or built are the European Galileo systems, Compass or Beidou 2 from China, the Indian Regional Navigational Satellite Systems (ERNSS), or in most actuality is named Navig Systems, okay, for Indian Regional. In this case, we have a systems regional for the country, okay, and the Japanese Quasi-Zenith Satellite Systems, KZSS. And the first space-based position system was the US Transit Systems. This is very important, transit, because the first space-based positions and the creative human, and the development of transition started in 1958. It was in operation from 1964, okay, until 1996. Predecessors of satellite-based position systems were ground-based systems, for example, LORAN, Zika, or Omega. Like their space-based counterparts, these systems have been designed for positions purposes and apply related principles for position determinations. The very basic principle is the transmissions of radio signals that a receiver can use to extract and estimate characteristics related to its positions relative to the transmitters. In these sections of the text, we study about types of orbits, the satellites with correlations and the Earth, okay? And the reason this paragraph, we have LEO or low Earth orbit, okay? So, uh, low orbits, né? And the altitude of less than 2,000 kilometers, okay? We have to GEO or geostationary Earth orbit, okay? The high altitude. In this example, we have 36,000 kilometers, provide a static satellite visibility, but requires higher transmitted power and high launch costs. Okay, we have two GSOs or geosynchronous orbits. Okay, and in this case, geosynchronous orbit is a particularly this type orbit or geo. Okay, but we have angle and inclination orbit. Okay, and this case we have a 0 degree in inclination of orbit, but this case we have different 0 degree inclined orbit. Okay, let's go. And the number and distribution of the orbits, as well as the number of satellites within each orbit, differ between these systems. In Figure 1.3 shows the orbits of pair of satellites within each orbit differ between these systems. Oh my god, excuse me. And Figure 1.3 shows the orbits of GPS, GLONASS, and Galileo through to scale. Uh, Alright. Besides the satellite constellations, further parameters play an important role for the achievable accuracy of GNSS. Okay, and in this picture, it's very important for this field of types they orbit. Okay, in this case, we have a GPS constellation of satellites in the center of Earth. Okay, this cycle or around this Earth, and 6 orbital planes with 4 satellites, 8. And in this case, we have 6 planes orbital. In each orbital, we have 4 satellites. Okay, in different positions. In case B, we have a GLONASS and contain 3 orbital planes with 8 satellites each. And repair this case orbital inclination with 55 degree in altitude and 20,200 kilometers. But this case, the orbital inclination is 64 degree approximately in altitude and 90,080 kilometers. Okay, and the KC Galileo, we have 3 orbital planes with 9 satellites, each orbital inclination 56 degree, altitude and 23,260 kilometers in the altitude. Okay, and this fact is curious because you are you know you know different altitude of Here, I can explain for you. In altitude, okay, this is a Earth, okay, and altitude, it's a measurement and the craft satellite in this case for sea, okay, but height, it's basically anyway measurement, okay, sure, let's go. Let's go. And and in topic, oh excuse me, comparison of global navigation satellite systems. We have three systems, and the first is GPS, second GLONASS, and third Galileo. Okay, number of satellites 24, 24, 30, and the number of orbits, orbit, orbit radius, orbit time, inclination, multiplex, code type, code length, ship rate, nav message length, modulations true. Okay, let's start. About GPS. And in this book, we have for GPS, we have a topic about space segment. Okay, excuse me, but I don't explain these minutiae for all of the topics. Okay, but if you interested, comment in this video, please. Okay, and we have two control segment about GPS, user segment, signals and carriers. Okay, for GPS, finish. And we have two GLONASS and less information. And we have two Galileo. In this case, we have information about the signals in your bands. Okay. All right. We have a finish for explain this topic about satellite-based position systems. And please, if you like it and like this video, comment and share with your friends, with your colleagues. Okay, and see you and see you about the video. Bye bye.